Right? You think we can start? Okay, hi everyone. Thanks for coming for the webinar today. Today we're going to talk about how to design effective API tests. It's a complementary subject to what the last webinar was about, which is how to build an API test plan. If you haven't seen it yet, go to the site. It's on YouTube as well, so you can catch that, but not now. Now let's listen to what we're going to talk about today. This is very interesting topic for me because I'm not, from what I've seen, a lot of people don't just put enough attention to test design. And I think that's sad, really. So maybe we can at least expand our minds and think about things that we're need to think about when we're going to test APIs, not just operate them. My name is Gil. Welcome. I'm a trainer and a consultant on all things that make software better for developers, testers, and so on. And what we're going to talk about today is sort of a common ground for developers and testers who want to test their APIs better. I'm also the author of Everyday Unit Testing, Everyday Spring Testing. You can get in touch with me through this email. And what I'm going to cover today is things that come up as part of my work, but also as part of my workshops on API automation. So if you're interested in that, let me know. Maybe I can help you. I'm on Twitter, but apparently I'm the only ones left there. But you can find me also on social media, all over YouTube, Facebook, LinkedIn, Xing, whatever, Mastodon, if I find myself there. Yeah, let's start. So I want to start with the goal and the goal of testing, because we sometimes forget we're doing our job, right? We write tests, automate tests, but there is something that it is basically we're investing time in something that needs to come up with some kind of a result. And the goal of testing is building confidence. But confidence for what? So we kind of think, well, we're testing our APIs or our system, it doesn't really matter, in some way. And therefore, we think we can apply this to production. So if it works in this kind of context or scenario, the word context will come up a lot today. Usually our system, the way our environment, the way we run it, is not exactly like production. Almost never is. So we kind of run some kind of automation, probably some manual, maybe manual testing, look at the results and say, okay, it's probably safe to move to the next step. From pre-production, it would be to production. But if you look in the continuous integration, CI, if unit tests run and they succeed, and then we think, well, it's probably okay to run the integration test or the API test. What's the thinking behind this? Well, this is okay for now. It will probably continue to work in another context, which may or may not be similar. And it will not waste our time. It will probably give us more information. So basically, this is like the confidence is about moving for the next step in our cycle of production towards production. So if this is the goal, we want the tests to achieve that goal. What do we want from a test? Well, first of all, when we're testing something like API or a unit or an end-to-end, it doesn't really matter. We want the test to tell us, well, if it passes, then we know it works. What it is, what this something is, we need to define, and we'll talk about that as well. But this is the building confidence part. But there's another job for the test that on failure, if something fails, then we want to know. We want to know where it happened, so we know and where it happened, so we can fix it and go back to building the confidence part. In order to do that, in order to have effective tests, basically this falls into this the category that I talked about. We need two things. We need test planning, we need test design. Test planning is coming up with what we're going to test. it's prioritizing, and we talked about these ideas of how to come up with these things last time. You can check out the webinar, how to create an effective test plan, API test plan on testingguild.com or everydayunitesting.com or my YouTube channel. Regardless of your choice, you'll find it. Usually we think about functional stuff, how things are going to work. Not always, but then we discussed heuristics for how to come up with these things like SF Depot. Again, if you want some details, go to the site and find out. And when the recording is going to be out, it's going to come up with the links as well. So test planning comes up with our list of, well, this is what we'd like to do, and then we prioritize it to this is what we can do. And then out of these things, what we're going to test, we need to think about how we're going to test these things. And we have options. And the more options we have, we can manage our time better. We can come up with the results of what we want, telling us, building the confidence, or telling us where something is wrong and how to fix it. And more than that, if you think about it, a test that is too hard to build or to automate happens to either go to waste our time. It's going to take some time, so we don't invest this time in something else, or we just drop it and say, well, this is too hard, or takes up too much time. We drop this case, and therefore we don't do it. We kind of miss out on the coverage that we actually want to do. So we want effective tests. This is basically what we're talking. And the rest of this session is going to be about a number of considerations or aspects of test design, what we need to think about. And this is like, some of it is technical, some of it is more, I won't say philosophical because it is down to earth, but it does open some ways of thinking and how to apply things when you try to design your tests. And these are things that are probably good to think about, and while you're doing that, before you're actually going to decide how to do this. Want to mention, this is, like I said, covered in some of my courses about API automation. If you're interested in that, one of the workshops, let me know either now in the chat or QA session window, or afterwards. I'll be here afterwards. Okay, so the first thing we're going to talk about is reality. And the reality is we're trying to test complex system. If it's not complex, somebody already built it, we'll probably buy something. We're developing something that is complex. And if you work with microservices today, anything cloud related, we have complex system that talk to each other, and sometimes they don't talk to each other because the connectivity issues. Sometimes they talk very slowly because latency issues. We have a lot of components talking to each other. Some of them we wrote, some of them, a lot of them, somebody else has wrote. We run in different environments that somebody else supplies. So basically, when we're testing an API or whatever, we're testing something that is already complex. And we have some kind of understanding and expectations about the system because it's complex. I won't say it's minimal, but it is not encompassing. We think we know how things should work, and therefore we say, well, if these things should work, this is how we should test them. Which is okay, this is the best we can do, but we need to remember one thing. Our thinking today and applies to only today. Our thinking may change over time because we're going to learn stuff, but things in production and how things are being used are going to change over time as well. So when we're thinking about what to test and how to test, we need to have some kind of information today of how we think, or maybe a plan of how to do this, how user will be using that, how different workflows will be using this API. This may be true today. This may be true after release. It may not be true in 2 months or 3 years from now. So when we're talking about reality, and we want to capture some kind of information, are these tests helping us to build confidence? At the beginning, we just have guesses of how things are going to be used. But after the things are in the wild, we're going to learn how they're used. And one of the things we want to do in order to increase this this kind of confidence is to design our tests to be as close as possible to what's happening in production. Different ways to get to how possible we can get there, but think about order of stuff, or maybe not just specific API. We thought that API is going to be used a lot. It's not used a lot. We thought about it's not going to be used once a day. It's used 10 times a minute. We find out things in reality that we can there apply and reapply to our test plan and test design. So first of all, need to be aware, not just like this is an API, test it. No, we need something a bit more than that, which leads me to this next one. And this is about thinking holistically. And thinking holistically, we can think about it like, yeah, well, I'll give you an example of how we look at how code works in production. But we also need to think about how we're going to test this API. And not only if this is the way to test it, which is a good question to start with, I agree, but we have other tests. We have other tests that, and I show you examples like another API tests that make it easier or cheaper to test our API or not. If we have other tests in the area, this will impact our decision on how to test our specific API. I'll give you an example in a minute. So we need to think about not just how effective the test for the API is, but also how this specific test that we're designing right now is going to fit into our own process. Now, when we're talking about our own process, we're talking about other tests that people are writing or not writing. Testability, we'll talk about that. Preparation for production, all kinds of things that we need to know. And if we're just looking at the lens of this is the API and I just need to run it and see if 2 times 200, it doesn't capture that. So we need to think about functionality, we need to think about processes, we need to think about architecture, and I'll give you examples as we go. One thing before we go further is people who are raising your hand, please write if you're trying to tell me something, please write them in the chat window. It would be easier, I think. Maybe I'll see you. If not, write them in the Q&A window. I'll try to answer as I go. I don't promise. I have a lot of pyramids to go through. So I want to mention the testing pyramid because this often comes up. Well, everybody sort of knows about the testing pyramid. It's not really a testing pyramid. It's called the automated test pyramid. And the pyramid tells us that we need to have more unit tests and less API tests and less end-to-end tests and so on. And the questions come, well, this is the plan. This is the model. Why are we talking about design? This is what we need to do. And I want to just like raise a few questions about the testing pyramid, because the testing pyramid tells us that we need to have more unit tests and API tests because they're cheaper. They're cheaper to write, they're cheaper to set up, they're cheaper to debug, they pinpoint the problem, and everything is true. But and API tests are better to have than end-to-end tests for the same reason. But let me get back to the effectiveness of tests. We want our tests to build confidence. Is there somehow in the model of the pyramid that tells us, well, this tells me that something works? The answer is not really. Think about it. If you had like 1,000 unit tests and this is all you had, how much confidence will you have in the system? Probably not much. If you had like 1,000 end-to-end tests, but no unit tests, how much confidence will, and all of them are passing, yeah. How much confidence will you have the system? A lot. The pyramid doesn't talk or speak about the value. It talks about the cost of test. And that's okay, it's a model. It doesn't have to be a plan. It doesn't have to be our plan or your plan. It's a model. And it's a high level model. If we're just taking it down to specific feature or specific APIs, we need to think about what we want from these APIs and the tests around them, not like where they fit inside the model. So context is very important. I give you an example. Kent Beck, who invented JUnit and test-driven development, and was one of the forefathers of extreme programming. He went to a few years ago to work at Facebook. He worked for a few years. And when he went there, he found out that unit test, or TDD, as he wanted to do it there, didn't work. And it didn't work because the logic that he usually built with tests, usually unit tests, we're talking about TDD, was kind of spread around PHP files. So building something like that did not fit the premise of TDD. It was for test first, did other models, but unit tests were kind of thrown out the window. And this is kind of tells you, well, this kind of model, the testing pyramid, doesn't fit everything. It doesn't fit every context. So you need to find out what your context is, probably know, and fit the tests for that. So don't just think that it has some kind of plan and everybody needs to go by this plan. I'll come back to the questions later. One of the things that we need to ask from our tests basically is what we want to learn. What will happen if this thing passes? What if these things fail, right? So basically, we see the green or the red. What do we learn from that? So I'm going to now jump into the code that we're going to show examples from. If you've seen my refactoring microservices, this comes from there. So basically what we're having is an API or two around scheduling meetings. We have this kind of architecture for service, like we have a controller that exposes an API. I'll show you the API in a minute. And it has some meeting logic in there and validation, whether we can create a meeting, schedule a meeting. It talks to the database through a repository and sends out invitation through Kafka to all the people who are invited for the meeting. That's the architecture for that. I'm going to show this in Java and Spring as an example, but every technology and every framework has basically the same topics that we want to examine. The API, the main API, is a post API, calls to meeting schedule with a body like this. And you start to get the topic and date and start time and length of the meeting. And some validation goes on that this is enough or invalid. And it doesn't really matter the whole thing. Let me just show the code. And so this is the controller. This is the meeting schedule API. It's a post. This is the meeting request. That's a JSON that basically translates into this kind of object. You have some validation here that looks at the data. If it's valid, it calls the meeting logic. Let me show you just some of the meeting logic is here. And when it's created, it's okay. Then invite participants, sends out the information. That's all the details we need for this kind of information. And this is very good code. I know I wrote it. It's separated in different responsibilities. It's pretty much follows the a lot of patterns like factory patterns or repository patterns. Things are separated very well. The validation is like sits in one place, the meeting logic sits in one place, and it talks to adapters, so we can separate and mock them. Very good code. And there's a reason for that in this example. Now, I was talking about what can I learn from tests. So let's look, I have a couple of tests here and different types of tests. So let's look at the unit tests for the validation. So what can we tell about unit tests? Unit tests ask from the validation or the meeting, is the logic working? This is what we learned from test. If it's working, the rules, the logic tell us, well, this is okay. It's probably going to, when we move to another further point in our process, this is going to continue. And if not, there's a problem directly here in the logic itself. So these are the unit tests. We have something else called data test. This is a Spring thing, but you can think about it as a regular data and database integration test. Spring calls it data unit tests. Not a very good thing. It's an integration test, but basically if it is okay, I can learn that data is saved correctly in the database. What is correctly? According to my expectations. I designed the tests, right? So I'm throwing some kind of a scenario, putting objects in the database, and I see if they are set up as the database schemas allows, and so on. So these are unit tests for the data. I have integration tests. Integration tests basically, let's look at that. So this is a Spring API test. It calls the API from the outside, but in a single process. And this is calling the logic, which calls the database and sends out the invitations. So this is like an sort of an API end-to-end thing, but not from the outside. Thanks for the questions. I'll be coming for them later. Okay, it's because this is also where I'm going. But it's a good question. So currently I have this kind of thing that checks sort of an end-to-end. It's a sort of, because this is a Spring test. A Spring test runs within the same process. So the database runs in process, the web API runs in process. Usually the person who would write them is a developer rather than a tester. But this is a thing. What can I learn from this? Well, if this passes, that means that within a process, which means without the possibility of connection problems or latency, the workflow that I'm checking goes from end to end correctly. What if it fails? Well, this is when we get to problems of integration tests or end-to-end tests. If it failed, I'm not sure what it's working, because if I'm looking at this test by itself, it doesn't give me much. I'll need to create a debug a lot and read a lot of logs on how to do this. So the longer we get to longer paths that we're testing, it doesn't matter if it's in process or not in process. Well, if there's a failure, it wouldn't tell us much, which is okay. We can live with that. We live with that every day. But that means that, going back to the slides, so that means that we need to figure out what kind of tests we need and build our own pyramid, really. And when we're talking about you or me, or this is like a team thing. Everything I talked about holistically is in the lens of the team, because at the end, we're going to run a bunch of those things. So a test by itself doesn't tell us much, but if we have like the unit tests and the API tests, we can do some kind of logic inference. So for example, we have component A, component B, and we have unit tests for A and B. and we have an API test for the API that calls A and B. So if we have the unit test for A fails, for B passes, and the API test fails, what do we know? The problem is probably with A. Logic, right? So having more tests, not just the API test, helps us with figuring out what our test should tell us, right? It should tell us if things are working. Remember, we need to ask what can we learn with these things, but also having the redundancy helps us with more information of where the problem is. Now, does this clash or does it fit within the pyramid? Sometimes it does, sometimes it doesn't, because you want to write enough tests to give us information in order for this information to help us what we learn, and from that what we learn to build this confidence. So it all starts from the end. So if you only have API tests, which is an option, that means that you kind of lose this kind of redundancy. You might want to write smaller tests, like unit tests and so on. And is it you? We're going to get back to that, but sometimes it's you, sometimes it's working with the developers to build this kind of, I don't want to call it a platform, but our own pyramid. Because at the team level, we'd like this kind of more tests in different levels because they give us more information. So the next thing, so I've talked about like from API to unit test, but that's not the only way to go small. Because basically we're talking about like APIs and we're talking about like paths in the code. Yeah, but we still like the API tests. So what can we do about the API tests? Well, think about it. I showed you already an example of an API test which runs within one process. The database runs in the same process as the web service and so on. That's not the only way to run. If it's a full microservice, we can deploy it as a microservice, right? We'll have the web service, we might have a gateway in front of that. The logic sits in one place and the database sits in another. Basically, we can spread it around like three or four machines or containers and run it from the outside. Like, for examples, I have an external end-to-end test. It uses rest assured for calling the APIs. I'm using now the local version, but I can run obviously on call it from another machine to another machine. And this is like an end-to-end test from the outside, like an API test, or you could use Postman to do that, or any other tool. But the configuration can vary because I already showed you in process one, this would be like something that runs the test and the web server running on this machine, and maybe the database too. Or I can spread it around, very different configuration. Which is the best one? Let's go back to what we asked before. What can I learn, or what do I want to learn from this? Well, if I want to learn, my code is working together without the possibility of failing on connections or latency and stuff like that. Having a smaller package or smaller configuration will help me learn that. If I want to see how things are going across machines, I can do that. I can distribute things across machines, run against those machines or containers, and get a result. If the success is fine, I can learn that in this kind of context, things are working together okay. If they fail, again, I need to read a lot of logs and see what's happening, and a lot of debugging. So these kind of things we need to be aware of. So we can actually, if we're thinking about design, if I want to learn about the integration of things, the smaller the package I will learn about, it will answer my question better. So think Ant-Man, go small. Does it replace the big one? It doesn't have to, but again, what do you want to learn from the big one? You need to define this, because if you're running the same test completely, same API, same setup, everything, only on the different configuration, you need to ask, well, what will I learn from the big one, as opposed to for the small? So if I have the small one, what another thing will I learn? And is that worth it? Next, I'm going to talk about the tool for the job. I already showed you my test with Rest Assured, and I can do the same with Postman. But when we design tests, we're kind of not thinking about it, but part of what we're going to use to run the test also comes from the design, and what we want to achieve from the test sometimes is important for us. So already give you an example. I wrote my code in Java and I had Spring tests running it, and Spring allows injection of objects as is. And if I wanted to look at a scenario where the database is disconnected, something like that, it's easier to do within a Spring test, because I can mock stuff and I can declare, okay, it's easier to mock or replace behavior because Spring allows it. And again, it depends on the technology. Whenever the code and the platform allows it, you probably want to do that. And you probably, if you want to do that, you check how your code is behaving when the database doesn't answer. Having the ability to mock things cheaply is better. If you think about, well, I'm going to call the API from Postman, how I'm going to do that? Maybe cut the code from the database, run another script that disconnects the database, use wiremock to simulate some kind of disconnect. It's not that it's not possible to do it, but the better tool to do it is makes it cheaper to test. Give you another example. Let me go back to the code again. So this is my test for the scheduler from Rest Assured, and here's another one. It's basically the same, does the same thing that the first part went, only the body that it sends through the post, it gets from a file. My file is sitting right there. It should, actually it sits right there. This is a JSON that I'm sending. Before I was like creating it on the fly from data, but this is like reading a file. Reading a file is something that's very easy to do within JUnit. That's my my test. So yeah, there's a small function here that reads the file as JSON, and I send it as a body. Everything's great. If I wanted to do the same thing from Postman, it's going to be harder. It's not impossible, it's going to be harder. For the people who know Postman, I can't really supply files from it. I need to like jump through a couple of hoops in order to supply this. It's either through a data-driven test, which supplies something in either a CSV file or a JSON file, then storing it in a variable, a collection variable, a global variable. Using that, then trying to see what we're going to do with this file or the data and so on. So this for input or references, this is how you do it. Postman allows you to do another thing, which is like run a server that will answer, you can get the data from there, not the file. But that means that this external server, it's not part of what you're testing, needs to be there every time the test runs. It's not that maintainable in terms of the test itself. So depending on what you want to do, you probably want to find the tool that helps you do it. I won't say like you want, there's not that the tool will not help you do it, but help you do it easily. And this is very important. So design of a test really comes down to also what's going to run it. And that's like when people like look at me in funny and say, well, we work with Postman. Do you expect us to use another tool? And the answer is, if it's going to make your life easier, yeah, why not? Of course, it comes down to whether you know how to code or not and so on, but it needs to fit your process. like I said, needs to fit the entire thing. Otherwise, like I said, if it's going to be too hard, you're not going to write or automate this test. Just going to drop it, leave it for chance or somebody else's, probably a user that will find out if it's working out for you or not. So tools, one thing. The environment we're going to run is also important. And when I'm talking about environment, I'm thinking about. I already discussed it, whether it's one machine, single machine, or multiple machines. Let's talk about if this test runs, what kind of environment it runs to. So, for example, I can run my test with a database that is freshly new, just for this test, or I can run it with a database that is full of data. Sometimes the test share a database in a development configuration, and in pre-production they will run by themselves. So I need to be aware of what's going to happen. Also need to be aware whether this test is going to run by its own or it's going to be run parallel to other tests. This comes down to understanding the impact of other tests on my test, because we're kind of developing a test. We don't think about all the other stuff that's going around, but it starts from a single point of where we're going to start and what kind of data we already have. We have expectations on that. Like if you're running with a full database, database do become full. So we might have a problem. Almost full database, it's going to experience some latency and maybe some disconnects. We need to understand how things are working. If the code has some global state that can be changed from different directions or different APIs, we need to be aware of that, because that means that if the test runs in parallel, there might be impact of other tests, and maybe we'll see something that fails in the CI, but when we try to reproduce it, we don't see it. So a lot of thinking goes into, well, how is this thing is going to run? And what's the starting point? So we need to think and figure this out. And it has some impacts. We'll talk about verification tests soon. But we need to think about, like, if we want to check what's happening if this API is called 10 times a minute or 10 times a second. We need to specify the tool for that, because we want to check what happens. What's the result of that? If we want to see who comes in first, we need to design our tests in a way that creates something that we control and reproduce to see the impact. Again, going back to what do we want to learn from that test. So maybe Postman will not be the greatest things for that, because maybe we need something like a load test tool that can call the APIs in concurrent threads. So we need to start from where we want to do, what we want to learn, and then start designing the tools, the environment, and so on. Okay, so I gave you the example of the database. And the idea is, where is the starting point? What is the situation in terms of data, of state, of connectivity? When we're starting to design a test, we have some kind of picture in our mind of where this is. Like the database is, of course, it's connected. The database, I can talk to the server is up and running. Another example that I come, the data is consistent in the database. So we design and we just do the operation. We expect things to work. Well, if the starting point is out of our control, we need to be aware of that, because what will happen, let's say the database is not connected. Okay, all our tests will fail. And we'll figure out what happened, because we'll see that after we run all the logs and see things, we see that our assumption of how this test was supposed to run on all his brothers and sisters, the assumption was wrong. We assumed the database would be connected, but it's not. So if you've seen me before talking about this, verification test is something that's near and dear to my heart. These are tests that we run before we run the functional tests, because we want to assume that the tests that we're writing are going to test just that. So we're kind of defining our starting point. So here's an example of a verification test. So this checks that the survey is up. Somebody answers. How do I know that? Well, I define it that if I get either something outside the 400 messages, 400 status codes, that means the survey is up and running. It may not work if I get 500s, like internal error or stuff like that. It's okay, but the server is up and running. Okay, so I need to say, well, server's answering and the database is ready and the right data is there and the right JDK is there or something like that. I can define the things that are important for me and then check that they are ready. I can also check, apart from things that are connected and running, data, like I said, data, maybe the queues, I need to make sure the queues that the application is using are empty, don't have anything in them that will impact our continuation. So if I have this, like I can look at designing my API test in two ways. It could be the optimistic way. The optimistic way means that I'm assuming everything's okay. How can I assume that? Well, either I am very optimistic or I ran verification tests before that. I checked that everything is okay. It could be the pessimistic way. Pessimistic way says, I don't trust anything that's run before it. I'll set up everything within my test, which is going to be expensive and not maintainable. Imagine every test that you're going to run has this kind of big setup just to make sure that everything is running. Doesn't make sense but to check that connectivity is running every time. But if you're pessimistic that every time you operate something, you probably want to run some piece of code that tells you, well, this is not connected or this is connected, you can continue. So verification is something that basically takes our assumptions of how the test will start and make sure, given feedback, of how our assumptions are really facing in reality. Okay, the next couple of things are more about coming together towards what people already asked me, and I said, well, this is like a team thing. It's not a developer or a tester thing, but this would be like, well, this is in the hands of the developers. Yes, it is. And if you're a tester, you probably want to talk to the developers to have this in order to facilitate easier testing. So what is testable architecture? Everything's testable. What is the opposite of testable architecture? It's not untestable architecture. It's expensive testing. Okay, if the architecture doesn't allow you to test easily, like I said, there's a price on that. You can either drop it because of lack of time and resources and so on. It's hard to set up, or you just drop it, or like you spend a lot of time on this because it's important, but then because it's very expensive, you spend a lot of time on that and you won't have time to do other stuff. So either way, you're going to drop stuff. We'd like to have this as cheaply as possible. Testable architecture is, let's talk about a scenario where like this connectivity, right? So I talked about Spring earlier. It's a dependency injection framework. I can easily replace stuff with mocks. And what happens if I don't have this? What if I run an API test within Spring? I can define what mocks I'm doing. If I'm running from outside, like with Rest Assured or with Postman, I can't do that. I can use WireMock or other more expensive way of mocking. Why is it more expensive? I need to record stuff. I need to store it. I need to retrieve it. I need to replay it. It's expensive in terms of setup. It's more fragile because it can break on different stuff. Upgrading data means re-recording stuff. So everything that I play with and I want to mock has some kind of cost associated with it. I'd like this cost to be as low as possible. Another thing I showed you, and I'll show you again. Let's go back to the Kelly again, and this time for the controller. So this is, like I said, a very good code. And in this code, I have the meeting validator in a separate class, and I could write unit tests for it. Already showed you. If you go back to the webinar I did on refactoring microservices, this is the end result. The beginning of the controller looks like this, where the validation is sitting here, basically. If I want to check just the validation, I can't. Okay, so having a separate class that I can unit test makes it easier to test. If it sits inside the controller, now I need to test through the controller. And that means creating different kinds of setup with different kinds of requests to run through the system. It's not easy. It's harder. It takes more time. Am I willing to pay this? Again, depending on how much I'm willing to do this, but what's the other option? The other option is refactoring the code. Who's going to refactor the code? The developers. Okay, so we need to be in conversation about the testability of the architecture because it has a direct impact on our design of the tests. And we want tests, the developers want them as well. Everybody wants to know that the system works because our tests build the confidence in the code. Only we need the code to behave in a certain way in order to be easier or, what have I done? Easier or more cheap to test. If we can't do that, then we're paying later with not testing. So this is about testable architecture. Remember, everything is testable, just a matter of price. But this is not the only thing. This is things are, if the code is separated or factored in a certain way. Sometimes it's not enough to test. The architecture needs to be good enough to expose what we want to look at the endpoint. Endpoint is not a good idea. At the assert level, we're going to assert something is working the way we expect. Assert or expect, depending on your framework. And we need to be able to observe that thing. Sometimes it's not observable. So up until now, I just talked to you about the schedule API, the post. What if it's the only thing in the world? Okay, so how would I know that the post works? Well, it specifies that it returns 200. Okay, if I see that it returns 200, is it enough to say that it's working? Yeah, probably not. I need other things. So if I had like apart from the post, a get meeting API and a get all meetings API, which I can call, I can verify that the post actually worked because I'm testing now not just the API, I'm testing the feature. And the feature is if I create a meeting, then I would like to see this meeting and the right status when I do get meeting details and get all meetings. So I need a get API. Sometimes it's not there. Sometimes it doesn't work. So for example, if I look at my controller, you can see that the get meeting API returns a 501 and not implemented. Why? It's not implemented yet. Question is, okay, how can I test the post without the get? Okay, I can do that. If you let me look into the database and I see that something is created in the database correctly, I can say, well, the post is working. But the developer, needs to expose this information for me or give me a tool to do that. Remember, this is a term of cost. It's possible to do this. But I need to do that. In order to do this automatically, I need to write something against the database to bring it to me in order to check it. So having an API like this, just because I need it for testing, not just because we need it in production, helps me test better. Most of the time we'll have something like this as part of the production, but sometimes we need something for testing. Here's another example. I have someone in my course that in his work wanted to see the rendering time. It's not an API thing, sort of related, but the rendering time of data that came through the API on his web page. And usually that's hard to test, hard to check. You need to spread around different logs. It's not in the production code, but you need, maybe you're going with Chrome DevTools and try to look manually how much time the API took and therefore subtract it from the beginning. It gets complex. And the easier solution is, well, ask the developers to write it for you, either in the page itself or to a log. It is for testing purposes, but it's for good purpose. And that is not wasting time on the testing, because the test itself becomes a lot easier and less expensive, because it's easier for the developers to do this and faster, and you get the results that you want. So my point here about both testable and observable architecture is work with the developers. So whole thing is a team thing. It's never just the developer. If the developer just dumps an API on you and says, well, test it, it comes with a price. And sometimes the price is, like I said, it's not that it's too big. It's going to be in the expense of something else, or probably going to drop it because the price is too high. Another thing I'm going to talk about today is also sort of developer adjacent. So sometimes APIs are working with some kind of authorization or authentication protocol. Maybe we need to pass a token in the header to make sure it works. And sometimes it's not what we're interested in. Okay, we need to do this because it works, because if, for example, we're running against a system with a gateway and the gateway does the authentication, then in order to check the functionality of the API, we need to go through the gateway and then to the API. It makes sense, but remember, we talked about, well, if this is what we're interested in, is this something that we really need to do? Because using a token can raises the price of the test. Sometimes smaller, sometimes by a lot, because if something fails, you won't know what failed, because we kind of created the chain of participants in the test, in the path, bigger. So we probably, with the idea of getting things smaller, to try this without the authentication. And this has a few caveats. First of all, we need to know where the authentication takes place. So we need to know how the code is built. Maybe the gateway does all the authentication. Therefore, what's ever left in the API is just a functionality we're interested in. And therefore, we can either replace the API test with an internal API test or a unit test. I don't know. It will give us the same answer of how does the functionality work. Sometimes part of the authentication or authorization is done in the code itself. And that means with something that we'd like to learn how to see. And therefore, we want to create different scenarios with the tokens, because token is part of our scenario as well. So first of all, we need to understand how these things work. Again, this is where developers are very valuable. They will tell us how things are working, so we can devise or design the test in a way that we can help us learn whatever we want to learn. So we need to know how to do that. Sometimes it's possible for the developers to just give us a back entrance, let's call it. It's not a good thing, but having an extension of just running the functionality without the authentication, because it goes through different abstractions, and we can test that. Again, it starts with, what do I want to learn? If I want to learn how the functionality behaves regardless of authentication, then give me just the functionality. If I want to see how it behaves with authentication, because it goes in different paths. Give me the right way to do that. It will be easier for me to design something if I know what I'm going to test. Again, this is something that collaboration between testers and developers really is valuable in order to spend our time in a more effective way. So what I did in the last sort of hour is talk with different aspects and consideration of things when we decided already what to test, what we need to learn, to decide, to define the assumptions, the environments, the starting point, know about how the code is built, how the code is run, how flexible can it be, and what can we replace or add in order to gain more information out of the concept of above from just I'll run a test and know that it returns 200. This is a lot of information to go on to build the confidence that we need. So when you're going to go back to your work, either by today or somewhere in the future, think about this, about your APIs, what you actually want to learn. Are there other tests that tell you already? If they're not, do you have a substitute for that? Can you decide of how things are working or running, and can you play with that? Because different mechanism will help you lower the cost of your test. Understand how the code is written, what is the architecture? Can you see things that are interesting to you? If not, again, work with the developers in order to create a way to do this in a cheap way, because this is what's important for us. If we can do this cheaply, we'll probably do this. If we want, probably we'll skip that and move into the next test. This is what I wanted to talk to you about today. Hope you had enjoyed it, or at least it was interesting to you. This is a good time to write your questions. There are a couple of more already in the Q&A box. Please write them there. I'll go to them immediately. Also meant to mention, again, this is part of the things and exercises that we do in my workshops about API automation, and think about that. And for the people who are living, who don't have any questions, who are living right now have to do that because somebody tells them. Thank you for coming here today, and hope to see you in the next webinars. Let's go to the questions. So Radek asked, what about performance of the API in situation when you are not able to get the requirements on the usage of the endpoint? Is there any approach to test the performance of an API effectively? So very good question. The answer is, as we've seen already, it's asking the right question. So it's not about testing it. What kind of questions do we want it answered? Usually when we're talking about performance, we're thinking about not having the same functional thing or same functional behavior, but according to time, like maybe it will take too much time, or will we support some kind of load until something actually breaks? And when we're doing that, we kind of twisting things around, usually exploring this situation where we are right now. And we kind of say, well, this is a situation now. If it's not going to play against by the same way in production, we're not testing it the same way, because what will we learn? We'll start to learn only what we're doing right now. And maybe this will be applicable to production, maybe it will not. So we need to understand what's the connection, how things relate of what we see and what we test here, and how we can apply that to production. If it's not, if we don't have the information of how things are being used in production, we're kind of guessing. So we probably want this kind of information. Otherwise, it's kind of a gambling thing. I think that I talked a lot about the collaboration between testers and developers. That's not the only collaboration that matters. Collaboration with DevOps or with marketing, with the product is very important, because this is the kind of thing that the information that they have will tell us, well, what we're seeing here is Well, up to 100 people using this API concurrently looks okay. But if you're not telling me what's happening right there in production, I don't have a direction. Do I jump to 1,000? Do I jump to 1,000,000? If you want better answers for me, in the time that you've given me, you probably be helpful for me to get this information. If it's not available, I'm just guessing. If that's what all I need to do, that's what I can do. Another question from Radek. Couple of internal IP. So that's the continuation of this. So I hope that answered that. Are the API unit tests written by software engineer or QA engineer? Okay, so first of all, if you go into implementation details, unit test is something that the developers writes. Why? Because basically is the developer writes the code and says, well, this has to behave in some way. And if I push some input to that, this is what I expect to write. This is why a lot of the time you test, sometimes if you test after the code is written, since you have the same expectation and you're sure that you've written something that works, you might have a test that checks your expectations badly, okay? If you're closer to the code, it's easier to write tests. What I've showed you, apart from the rest assured things, is something that is easier for the developers to write. So if the developers write tests, that means that you can guide them where to test. I think that is a lot of help to you if they will write the tests. If they don't write tests, you probably won't help you both in the testable architecture part and the visible architecture part. If quality is not part of what the developer's goal is, it's hard to get some collaboration. I hope it's not the situation for you. The rest assured things that I wrote, along with some maybe Postman API test that I can write, can either come in a way where I have some relationship with the code, or I can do this like a black box. The more I know about the code, whether if I've written it or know how to read it or can change it, I'll be able to test better. I'll understand what I can mock, how I can mock it, and so on. If it's only black box, it's harder. It's going to be expensive to do it. May that be the best way to do it. So who writes the test? The closer the people to the code will write the tests. The API tests can go either way, again, depending on your knowledge of how to code. The more we get away, again, developers can write anything, like from Selenium tests or mobile tests, they can do that. They probably won't do that, but unless somebody makes them. Usually the closer to the code is something what the developers do, but you can pair with them. You can tell them, can you check that this kind of test in a simpler scenario when you don't need to distribute everything over multiple containers, just run it in a single process. If they are aware of this option, it will make both of your life easier, because you will get the answer, are these things working where they're not talking over machine, over connectivity problems, and then you can spend more time about checking a wider distributed system. Long answer to a very small question. Funny to see a pyramid metaphor this time of year. Ha ha ha. Thanks for clearing path through the sea of confusion. I hope I cleared the path in the sea of confusion. That created a whole new puddle. How does Postman help in performance testing of a set of APIs? It doesn't. Postman is not built to do this. Postman is for functional testing. Yes, it gives you an answer of how long something took, but that's it. Basically, if you run it multiple times, you may be able to compare the length run of each request. It doesn't give you concurrency out of the box. You really have to do something in order to convince it to run concurrently. There are other tools that do that. What else? That's basically it. It runs things more sequentially. It's not a load testing. It's a functional API testing tool or operation tool. The context of multiple request runs is something that you have to code yourself and decide where to put this code. And Postman is not a good IDE. It's not a good coding environment. Don't use that for that. Other tools are better for Postman, other than Postman for performance. We have only one API to test in performance testing. That API does import or export functionality. How do we test that through Postman? Again, if the API allows you to do that, if it's one API, testing performance testing, it could be like multiple APIs, but in GraphQL, it's like a single API. So it's like single API with different scenarios. But if it's a REST API, it really depends what will make your life easier. A tool will help your life easier. So like I showed you, if it's exporting and importing data, it's important for that. If the tools can see and run multiple concurrent things, it will help you. Postman does not allow this. So probably not the tool for the job. What about test data? Who is responsible for test data? Okay, very good question. So let's see what we've gone through. We've gone through test planning. Test planning says, well, we're going to test this kind of feature or API with these scenarios. That means with this kind of setup and data and so on. And therefore, and part of that will be, and a reference data that I need to supply in order to check that the result that we got is correct, like comparing meeting information in what the response is in our example. So who's responsible for test data? I would say the person's writing the test is really the person responsible for test data, because they can actually specify exactly what they're going to send into the API, what they're going to look at the result. So there is it the developer or the tester? Again, the person who's writing this, hopefully it's a collaboration of both, so you can decide which one is working on it. It is part of the collaboration to think about. It's not a responsibility of a role. Okay, so I hope I answered the questions. If I didn't, please send me an email, gil@testinghill.com. I'll try to answer that in a blog or somewhere else, and I'll try to make a more detailed answer. Other than that, thank you for coming here today. I hope you enjoyed it, and I hope to see you next time after a while with the next webinar. Thank you, and bye-bye. Hey everyone. If you enjoyed this video, be sure to like, share, and subscribe for more. Thanks for the support, and remember, live long and test.